This video is a short summary of some of the important aspects of natural disasters, lab number 2, flood frequency analysis. One of the things to note is the graph paper that's used to plot the data in this particular exercise, and one can see that it is not a standard or common type of graph paper. Rather, it's what's called a logarithmic paper, in which we plot logarithms or exponents of values on one axis, and in this case we have what's called a logarithmic probabilistic axis for the other axis. And that's a somewhat sophisticated mathematics, but what's good about a piece of graph paper is that you can plot the data points on it just the same, and they will appear in a much more useful way using this special form of graph paper. Additionally, the data comes to you in the form of a spreadsheet, and that's what the spreadsheet looks like when you immediately download it. It is entirely fine for you to go ahead and do all the calculations by hand with a hand calculator, or even worse, but I'd like to make a demonstration here of how you can use the power of the spreadsheet to make this job easier. First thing a spreadsheet can do for you is it can sort, and one of the tasks in this lab is to organize the data from largest to smallest. In this case, to sort in a spreadsheet like this, you only have to click somewhere in the column that you want to sort by. So I'll click here, ask for sort, and I'll sort from largest to smallest, because that's how that's the order that we use in this that is defined in this type of analysis. And now it has the biggest value, which I believe is one of the answers to one of the questions. And the years got moved around with that just as well, and all the way down to the smallest value. So that's one use of a spreadsheet. Additionally, I can go right ahead, and that's just text. That has nothing to do with computation. I can go right ahead and use the spreadsheet to calculate an average for me. So I can use a built-in function, and you can look these up and to learn the thousands of functions that there are. And I can just say take the average. I drag my pointer across them all, and now I'm asking the computer to calculate the average of all the values in this column from row 2 down to 26, and I do check, and that's the average discharge for each year, average of the peak discharge that was recorded each year. So that's kind of an average annual flood. Additionally, I can go right into this and assign that a value of 1, and so that would be the largest value. It has a rank of 1, and I actually have the formula for frequency analysis built in to this particular column, which is handy as heck. And I can also go right ahead and type in all the values here, and as soon as the value is typed in this column, this formula has enough information. It has the number of years of record, the rank, and it can therefore do the computation and get a recurrence interval. And if I don't want to type all the way down to 25, I can say equals that plus 1. So that means just make that one, make every cell from here on down, and I'm doing Control D for the fill here, make that every cell from there on down equal to 1 more than the cell ahead of it. So I've done the whole job now. To finish the exercise, you just need to plot a recurrence interval on one axis versus a discharge on the other axis. 25 points connect the line, and then every other computation will be a direct read from the graph that you create.